So I welcome all of you. I hope I'm audible. Am I not audible? So I welcome all of you. I hope I'm audible. Oh yeah. So it seems we are live. So few students have joined. I welcome all of you. And I welcome all of you. A very happy Children's Day to all. Let's begin in a minute or two, or rather maybe 3 minutes. Let's wait for everyone to join and then we begin. So I welcome you, Shweta Sankar. Okay, let everyone join. We'll start in a minute or two. I mean, I'm ready. Just that I'm waiting for everyone to join. There are students still joining. So welcome you, Sanjeev Kumar. Good evening. Good evening, Sweta. So yeah, uh, so Guru Swami, I welcome you. We'll be starting in a minute or two. Don't worry. All right, then let's begin. So yeah, we are well into the session and now we can begin, I suppose. We have waited enough. I welcome all of you and very happy Children's Day to all of you. So today's topic is related to sets. So it's regarding cardinality and counting questions. So little bit of permutation combination would be involved, and I hope you are ready for that. Yeah. And as we move ahead, related to sets, I may tell a thing or two, but related to little bit of permutation combination or at times it may just well be some common sense. Regarding that, I would expect that you turn up and you put your mind to it and try solving them. Again, a very happy Children's Day to all of you. Let's begin. Yeah. So before we go for questions, I hope the slides and all are visible. Before we go for questions, let me talk a bit about sets, and which will be of use. You know, I mean, whatever we are talking now, it would be of use for the questions that lie ahead. Yeah. So first of all, I suppose everyone is aware what set is. Set is essentially a well-defined set of things. Yeah. Now those things can be number, or those things can be anything as such, just that it should be well defined. In fact, your family members names put together forms a set, which is your family set, so to speak. Yeah. And similarly, you can have set of natural numbers which will be 1 2 3 4 5 6, and in fact it will be an infinite set. Yeah. You can have set of prime numbers less than equal to 20. So here prime numbers less than equal to 20 would involve what elements and how many elements. So the elements will be 2, 3, 5, 7, 11, 13, 17, 19. So apparently, yeah, 8 elements, and it will be a set and it is a finite set. So I suppose you know what set is, point one. Second, you should know what subset is. Yeah. Suppose we have a set A which consists of all the prime numbers which are there, which are less than equal to 20. So 2, 3, 5, 7, 11. Oh, what happened? Oh, my bad. I hope this doesn't affect. Hey. Okay. So maybe I'll keep it this only less than equal to 10, because as I'm writing here there seems to be some error. Anyway, so okay, the error is apparently is not visible to you, but there is some error I'm not able to write. Anyway, so here number of elements in set A is what? 4. And we'll talk a bit about these small concepts, and then there will be a decent number of questions that lie ahead. But just so that most of you are comfortable, we talk about such things in the beginning. So number of elements in set A would be what? 4. Now, what is a subset? A subset is a set which contains any number of the elements of set A. Yeah, any subset of set A would contain any number of elements of set A, so to speak. Yeah. For example, B having 3, 5 is a subset of set A, and we say what? B is a subset of set A. Now again here, strictly speaking, this means subset. Yeah, this capital C kind of thing, and with the horizontal line, this means B is a subset of set A. Yeah. And this would mean what? B is a proper subset of set A. Now, what do we mean by proper subset? So, proper subset would mean what? If B is a proper subset of set A, that essentially means B does not contain all the elements that are there in set A. That means B is not equal to set A. B is a strict or proper subset of set A. That means there will be at least one element which is there in A but is not there in B. Yeah. So that's what it is. Now, given that number of elements in set A is 4, yeah, what is the total number of subsets of set A? Yeah. I would want you to answer. Let's see how many of you can think about it. Total number of subsets of set A. And as you calculate this, let's talk about power set. Power set of set A essentially, is a set containing all the subsets of set A, containing all subsets of set A. Yeah. So number of subset of set A is same as saying number of elements in the power set of set A. I hope you are getting the point. Yeah. Uh, I'm waiting for response as such. So there's always some delay in when I speak and when you get to see it online. So that's why the responses from your side may also take time, and that's all right. So yeah, number of subsets. Can you think of that? A little bit of permutation combination is expected because we are talking about counting problems here. No response till now, apparently. Okay, Sanjeev is saying 4. Think about it. Okay, Silva Kumar is also saying 4. Good. Shweta is also saying 4. Okay, 4 is not correct. But anyway, kudos to you for putting the effort. Yeah, it will be 2 to the power 4. Yeah, which essentially will be 16. Now, since you got it wrong, let me explain it a bit more. Yeah, so that you get a feel of it. Yeah. See here, what will be the number of subsets of set A? Yeah. So think it this way. Pay attention. See, in any subset, 2 may or may not be there. Yeah. So 2 has two options. Even 3 may or may not be there in that subset. So 3 may be there or may not be there. So two options for 3. Similarly, two options for 5 may or may not be there, and two options for 7 may or may not be there. Yeah. So that takes you to 2 to the power 4, which is 16. So that means, suppose if number of elements in any set, let's say, what will you say? Let's say set C. Number of elements in set C, let's say, is K. Then number of elements in power set of set C, which is same as number of all possible subsets of set C, is 2 to the power k. That's what it is. So make sure you take a note of it because questions ahead would be using this. Yeah. Yeah. And apart from that, I suppose you are already aware what do you mean by intersection, what do you mean by union. Yeah. These are some important prerequisites. So here, let's say, suppose there is a set X which is 2, 3, 5, 7, and there is a set Y which is 1, 2, 3, 4. So X intersection Y would be what? So I'm using this particular slide only. Why? Because next slide onward there are questions. I was expecting that I would be getting quick correct answers. But anyway, that's all right. I'm sure it will be fun because it's always fun to learn something and to apply that. Yeah, so it is going to be fun for sure. So a number of what will be the set X intersection Y? So it will contain all the elements which are there in X as well as Y. So that becomes what? 2 and 3. Yeah, that means so X intersection Y stands for this. It is a set containing all the elements which are there in X as well as in Y. So there are just two elements which are there in both these sets. So that's how it is. What about X union Y? So it is all the elements which are there in X or Y or both. So that means what? It will be 1, 2, 3, 4, 5, 7. Yeah. Number of elements which are there in X or Y or both. That means X union Y. So this U means union. This inverted U means intersection. Yeah. Just to give you a feel of it. This U means union and this Inverted U means intersection. Yeah. All right. So I hope this is clear. Yeah, Selva, Kumar, and Sanjeev. Now I've seen your responses. You're right. 2 and 3 would be there in the intersection. Yeah. And likewise. So I hope everyone is fine here. And importantly, as we write X union Y, since 2 is there in X and Y both, we don't write 2 twice. We write 2 once only. Yeah. So for clarity's sake, number of elements in X intersection Y would be what? 2. And number of elements in X union Y would be what? 6. Think about it. So yeah, some decent questions, and all the questions that are ahead are some previous year questions only, so that you know, you are very much benefited by this session. Yeah. So let's keep rolling, I suppose. Here we go. So here set A has m elements and set B has n elements. If total number of subsets of A is 112 more than the total number of subsets of B, then the value of m multiplied by n is. Quickly think about it and then we solve. You may go for a bit of observation or whatever. Yeah, think about it. So let's move ahead. I've given you some time to think. In case you are still thinking and trying, continue doing that. In case you're looking for a hint, you can see to what I'm about. I mean, what I'm about to do. Yeah. So here, the number of subsets of A would be what? 2 to the power m. The number of subsets of B would be what? 2 to the power n. And it says number of subsets of A is 112 more than number of subsets of B. Make sense? Now, either you can just go by observation, and a quick observation should give you, and you should be able to see m is 7, n is 4. Check it out. 2 to the power 7 is what? 128. 2 to the power 4 is 16. So 128 minus 16 is 112. Now, suppose you are not able to observe, how would you do? You can take 2 to the power n common. Of course, m is supposed to be greater than n because 2 to the power m minus 2 to the power n is 112. So as you take 2 to the power n common, you get 2 to the power m minus n minus 1, which is 112. Makes sense? Yeah. Now this is definitely supposed to be odd. Why? Because clearly m is not equal to n. M is greater than n. So this will be even. I mean to say this will be even, and uh, yeah, this will be even, and even minus 1 is odd. So here, this 112 you can write as what? If you see carefully, it is divisible by, it is in fact, you may say 4 multiplied by 28, or you may say 16 multiplied by 7. So you can say 2 to the power n is 16, and 2 to the power m minus n minus 1 is 7. So that means n is 4, and 2 to the power m minus n is 8. So that means you may say m minus n is 3. So n is 4, so m will be what? 7. So here m multiplied by n turns out to be what? 28. Make sense? Let me know in case there is any doubt. So yes, Sanjeev, you're right. 28 is the answer. I hope everyone is able to understand. If there be doubt, you can ask. Let's move ahead. Yeah, and yeah, you can ask, and I may go back to the previous question also. Not an issue. Just make sure that you understand and grasp all the questions. Now here is this another question, and make sure that you have fun with maths today. Yeah, uh, and try your best to solve questions on your own also. And even if you're not able to solve, anyway, I'll be helping you out. So there's the set S containing the first 100 natural numbers. The number of non-empty subsets of, I mean, we are calling that subset as A. So number of non-empty subsets A of S says that the product of elements in A is even is. See here, non-empty means what? Non-empty means there should be at least one element of set A in, sorry, there should be at least one element of set S in the subset A. Yeah. Any set which does not have any element in it is called as empty set or null set or void set. You might have heard it. In case you haven't, now you have heard. Yeah. Subset, you know, non-empty subset, now you have come to know. Now we want, you know, the total number of such non-empty subsets of this set S such that the product of elements of that subset is even. Now think about it and tell me which is the correct option. Okay, Silva Kumar is saying B. All right. Yeah. Rajni is also saying B. Yeah, it seems B is correct. You are thinking right. Yeah. So now let me help you out, especially those who are not able to think. Or yeah, Sanjeev is also saying B. Good. So hey, where is Rajni gone? I saw Rajni commenting. Archu is saying B. Yeah, good. B seems to be correct. Think about this. Yeah. For the product of elements to be even, at least one even element should be there. Consider this. If all elements are odd, their product would be what? Odd. Even if one element is even, the product becomes even. So that means for product of elements to be even, at least one element has to be even. How many even elements are there? 50. How many odd elements are there? 50. Because among the first 100 natural number, there are 50 even elements and 50 odd elements. Yeah. So that means what? You know, you may say each of these even elements, or rather, you may say each of these odd elements has option to be part of the subset or not be part of the subset. So it becomes 2 to the power 50. Yeah. Multiplied by. Think about this. There has to be at least one even element. So you may say each even element has two options, whether be part of the subset or not be part of the subset. So it becomes total 2 to the power 50 ways minus that one case when no even element gets selected. No even element is part of the subset. I hope you are able to understand. Think about it. So at least one even element is supposed to be there. So each even element has two options, whether be part of the subset or not be part of the subset. So, you know, 2 gets multiplied 50 times. So 2 to the power 50. And it's very similar to the way we had, you know, talked about number of subsets and all. Yeah. So I hope you have grasped the basic idea there. Minus that one case when all the even elements turn out to be not be part of the subset. Yeah. I mean, no even element turns out to be part of the subset. So you subtract that one. And, you know, each odd element has, you know, two options, be part or not be part of the subset, and we are cool even if no odd element is part of the subset. So this becomes the answer, and hence you know, you may say B is the correct answer. Yeah. So you may say answer is B. Yeah. So previous this, let me just remove this and let me write answer below only. Yeah. Answer is 28. So yeah, let's keep rolling. I hope everyone is able to understand. We go for this one more question, and then perhaps we talk a bit more about some other concept, and then take a few more questions. Yeah. So there is a set X, and this is again a good question. So we are having a good variety of questions here. There is a set X containing the elements 1, 2, 3, 4, 5. Now we want number of different ordered pairs y comma z, where y and z both are subset of X. Yeah, you know what this means. Elongated C and dash down to it. In the beginning we had discussed that. So y and z are subsets of set X, and we want all the ordered pairs y comma z such that y intersection z is empty. Now you know what do we mean by intersection, this inverted U. That's all what we have talked about just before these questions. Yeah, so think about it. This is again a good question. Yeah, you may consider clicking the like button on the video, so that this becomes part of your liked videos list, and you may refer it back. Anyway, in general also, we in life we should be appreciative of things which benefit us. Yeah. So those who have joined recently, I wish all of you a very happy Children's Day. Yeah, so I suppose everyone would have given some thought. I don't want to spend too much time, because then it becomes boring. Yeah. So those who are able to think, good. Those who are not able to think, pay attention here. Yeah. So here y and z are subsets of set X, and we want number of ordered pairs y comma z, given that y intersection z is empty. Empty means there is no element in y intersection z, which means what? There is no element common between subset y and z. So I hope it is clear. Yeah. So Sanjeev is saying B as the answer, 3 to the power 5. Okay. Yeah, you're right, Sanjeev. Selva Kumar, you're also right. Good. So that means you have this basic understanding of counting and all. Yeah. Again, we have not taken, in fact, ahead also, we may not be taking too difficult questions or too involved questions. The purpose is just to, brush the basic and invoke the common sense. That's what the major point here is. Of course, I mean, as we move ahead, things are going to become better or a bit difficult or whatever. But the point is, I am taking it from very basic. Yeah. And those who are new to sets may find it difficult, that because I had told that certain things are prerequisite. Although I said certain things are prerequisite in the beginning, we did talk about those certain things which were useful in these questions. Anyway, so here y intersection z being empty set means what? There is no element common between y and z. And what are y and z? They are subsets of this set X. Yeah. So that means each element of this set X in general would have had how many options? 4 options. Each element can be part of y and z. I mean, any particular element, or rather each element has these 4 options. What 4 options? It can become part of both the subsets y and z, or it can become part of y but not z, or it can become part of z but not y, or it may be neither part of z nor part of y, so to speak. Yeah, you can see that, isn't it? Think about it. There are just these 4 possible choices that each element of set X would have. Yeah. Now think about it. The deal is y intersection z is supposed to be empty set. That means there should not be any element common between y and z. That means there shouldn't be any element which goes to both y and z. So that means all the 5 elements are left with these 3 options only. Either they go to Y but not Z, or they go to Z but not Y, or they don't be part of Y or Z both. Yeah. So that means each of the 5 elements of the set X would have these 3 options only. So what will be the total number of ordered pair Y comma Z? It will be 3 multiplied 5 times, which is 3 to the power 5. Why? Because each element of this set X would have these 3 options only. No element can be part of both the subsets Y and Z. Why? Because Y intersection Z is supposed to be empty. That means no element common between Y and Z. Yeah. So that's how it is. Yeah. So here in the beginning, whatever ideas we have discussed, majorly those we have used here. Yeah. Let me know in case there is any doubt. Yeah. So let's keep rolling. So before we move ahead, now let's talk about cardinality problems, rather the basic of the cardinality problems. So here pay attention. Let's say there is a set A represented by this circle. There is a set B represented by this circle. Yeah. What is A union B? Yeah. If you see carefully, A union B is this entire region. This is what A. Uh-oh. My bad, my bad. This is, I can't write above, so I have to write a bit below. The above part seems to be sensitive to some other thing. So this whole region is A union B. I've used light green, but I hope it is visible enough. Yeah. And what about A intersection B? A intersection B is the region common to A and B. Makes sense? All right. So here, pay attention to this equation. Can I say number of elements in A union B is number of elements in set A plus number of elements in set B minus number of elements in set A intersection B? Think about it. Number of elements in set A union B is this. And it's not so difficult also to understand. Yeah, ultimately we would be using this in upcoming questions. So number of elements in set A union B is what? This whole region. Number of elements in set A would be what? This whole region, this circular region representing set A. Yeah. And number of elements in set B would be what? It would essentially be number of elements in this region. Yeah, I hope you are able to follow. Yeah. Now, if you see carefully, this region has been counted twice. It should have been counted once, but it has been counted twice. It has been counted while counting the number of elements in set A, and also counted when we counted the number of elements in set B. So it has got counted twice, this A intersection B part. Ideally, it should have been counted once only. So we subtracted once. Yeah. So I hope everyone is clear with this, and we can straight away go to the questions. If you want, you may take a note of this equation, and the questions ahead would, involve its application. Yeah. I hope everyone is fine and has taken note of it. Let's move ahead. Try thinking about this question. A survey shows 73% of people working in an office like coffee and 65% like tea. If X denotes the percentage of them who like both tea and coffee, then X cannot be. Actually, it seems that I have directly taken a very good question. Uh, okay, so these all are good questions actually. Yeah. So okay, fine. Directly we have taken something good. So let me talk a bit more about some more relevant concepts. Yeah. So pay attention. Can I say number of elements in A intersection B will always be less than or equal to number of elements in A or number of elements in B? Think about it. The A intersection B region, the A intersection B region will always be, less than or equal to the region of A or region of B. Think about it. It's common sense, right? Yeah. So I suppose that's what is being asked here as such. Yeah. In fact, both these questions are related to this understanding as such. Think about it. And of course, a number of elements in set A intersection B can't be negative, obviously, yeah, because number of elements can't be negative as such. So yeah, think about this question then. So I hope you have read the question. For your help, let me talk a bit more about the one more sub concept involved here. Yeah, I hope everyone has read the question and you may try answering it. Here, sub concept involved will be what? Number of elements in A union B will always be less than or equal to number of elements in A plus number of elements in B. Yeah. In fact, you can also say number of elements in A union B will always be less than or equal to number of elements in the universal set. Universal set means what? The biggest possible set in a given context. Think about it. Yeah. So we go for this next question. I hope, okay, in case you want to take a quick note of it, make sure you take a quick note of it. Maybe I'll give you 10 seconds more. Yeah. So think about it. I suppose you would have thought about it. So Silva Kumar is saying A. Okay, let's solve this. Yeah. Let's say those who like coffee is 73, of course, percent. So total, percentage will be what? 100, universal set. Those who like tea is 65%. Yeah. And X is all those who like, I mean, X is in percentage. So all those who like, tea and coffee both. That's what X is. Yeah. So I can say X should be less than equal to 65 and should also be less than equal to 73. Make sense? So that means X should be less than equal to 65 because this is more strong constraint. Why? Because intersection, C intersection T will surely be less than equal to C or T, right? So that means here, in fact, all these four options satisfy this. Interesting, right? So what other thing you would have? You may say number of elements in C union T is always less than equal to number of elements in universal set. Yeah, think about it. So that means number of elements in C union T will be what? Using the formula that we have seen in last, this last slide, check it out. So here, less than equal to this means 100. So NC is what? 73. This is 65. This is X. So less than equal to 100. So you may say X is supposed to be greater than equal to, if you see carefully, uh, 35. So you have what? 38. Hmm. Yeah. So X is supposed to be greater than equal to 38. Check it out. I hope we are doing calculation right. As you have what? 138 minus 100 is 38. Yeah. So X is greater than, as you rearrange, yeah, basic inequality. So that means B, X cannot be B, the option B. Yeah. So yes, Sanjeev, you're right. I suppose you are the only one who has given answer till now. So B is correct answer. So X has to be greater than equal to 38. So that means X cannot be less than 38. So B is correct answer. I hope it is clear. I suppose the next question also similar question. Let's see if you can do it. A survey shows that 63% of people in a city read newspaper A, whereas 76% read newspaper B. If X percent of the people read both the newspaper, then a possible value of X can be. All right. Okay, so it is see, previous question asked what the value cannot be, and here they are asking what a possible value of X can be. So think about it, and let's see how many of you can answer. So interestingly, we have taken some good questions up front. Yeah, I suppose you have given some thought. Here, newspaper A, how many read? 63%. Newspaper B, 76%. Universal set, I can say 100%. Yeah. So, and this A intersection B, let's say, is what? X percent, reading both newspaper. So, X is supposed to be less than equal to 63, X is supposed to be less than equal to 76. Yeah. So, since it is supposed to be less than equal to 63, it can't be the C option. Yeah. Apart from that, this would also hold, just as we have used in the last question. So, NA plus NB minus NA intersection B is supposed to be less than equal to NU. What is NA? 63. This is 76. This is X less than equal to 100. So that means X is supposed to be greater than equal to, you have what? 139. So 39. Yeah. So X is supposed to be greater than equal to 39. So that means even A and B would get rejected. Yeah. So that means D is the only correct answer. Yeah. So yes, Sanjeev and Silva Kumar, you're right. D is the only correct answer. I hope this helps. Think about it. Let's go for the next question. Read it a bit, and then you have to answer among these options. In a certain town, 25% of families own a phone and 15% own a car. 65% families own neither a phone nor a car, and 2000 families own both a phone and a car. Yeah. Consider these following statements and you have to tell which of these are true or correct. So I suppose we have indeed taken some decent questions. So after this, let's take a one more variety question, and then of course we can go for till now we have been talking about two sets. We may even talk about three sets similarly. Let's see. Maybe after this we'll take a couple of variety questions. So till now we have taken decent questions actually. Any answers? No answer seems to be coming. Anyway, we'll not keep waiting. Let me help those who are still thinking. So here, number of you know people or families having phone is what, 25%. So let me take it as 25. Having car, 15. having neither phone nor car. Yeah, so here, in case you are able to think, good. In case you were not able to think, let me help you here itself about this concept, which is called De Morgan's law. Yeah, so you can say having neither car nor phone. Yeah, that means car is also not there and phone is also not there. That is what? That is 65%. Yeah. Now this essentially is C union P whole bar. Yeah. Now this is the concept of conjugate set actually. Yeah. This is the concept of conjugate set. So to give you a feel, let me go back to this and this thing. Let's say this is universal set. This is universal set. Hi. Okay, I can't write like this. So maybe I'll have to write like this here. This is universal set. Yeah. So here, think about it. Yeah. What is, A union B, is this green part. So conjugate means what? Suppose number of elements in A bar is what? Total number of elements minus number of elements in set A. Yeah. So all the elements which are not part of set A is said to be part of set A bar or A conjugate. Yeah. For this question you have displayed, I'm not sure what Sanjeev what you're saying. Anyway, number of elements in A union B whole bar will be what? It will be number of elements in universal set minus number of elements in A union B. Yeah, makes sense. If you see carefully, A union B, so A union B whole bar would be what? It will be this region. Where is the marker? Yeah, it will be this region. Yeah, all the region outside A union B. Yeah, so this essentially becomes what? A union B whole bar. And if you see carefully, since you know what we mean by conjugate now, and you also know what we mean by intersection, this is same as A intersection, sorry, A bar intersection B bar. Yeah, this is same. They are the same. Yeah, all the region outside outside set A intersection all the region outside set B. I mean the common region which is outside A and outside B. Even logically you can think it is same as A union B whole bar. So that's why we said number of elements in A bar intersection B bar is number of elements in A union B whole bar. Yeah. So with this understanding, so yeah, Silv Kumar and others are saying D option. Oh, many of you are saying D option apparently. Or is this the comment related to previous? Yeah, I think previous question you have commented about apparently. Anyway, so think about this. This essentially means what? And what about number of elements in universal set? It is supposed to be 100. Makes sense. So that means 100 minus number of elements in C union P is 65. So number of elements in C union P is what? 35. Check it out. And there are 2000 families which own both car and phone. So number of elements in C union P is what? Number of elements in C plus number of elements in P minus number of elements in C intersection P, right? So that means 35 is equal to 25 plus 15. So if I were to write it in the same order, let me, so you have 15 plus 25 minus, number of elements in C intersection P. So number of elements in C intersection P will be what? It will essentially be, if you see carefully, 5. Yeah. And mind that this is 5% by the way. So that means 5% of the population is supposed to be what? As per their information, it is supposed to be 2000 families. So that means the total population will be what? Now it is, just a matter of percentages. If 5% is 2000, Yeah. So, total number of families will be what? 5% of population is 2000 families. So, total population would be how many families? You multiply by 20. So, you have 40,000 families. Yeah. So, that means C is indeed correct. Yeah. 40,000 families. Yeah. Uh, 40,000 families live in the town. C is correct. Yeah. It says 5% families own both a car and a phone. Yes, we have got this. 5% families own both car and phone. So even A is correct. And it says 35% families own either a car or a phone. Absolutely. Or means union. So 35% families own either a car or a phone. So even B is correct. Good. So your answer should be what? C. Yeah. So I hope you enjoyed this question. Since we have already spent a lot of time, let's go for a couple of quick questions. Yeah. One easy question and one a bit better question based on that easy question. Yeah. So I hope you are able to appreciate that whatever we are discussing, we are talking about the concepts involved simultaneously. Yeah. Simultaneously means either before the questions or during the questions. Any doubt? I suppose everyone is fine. Let's keep rolling. Think about this question. Oh, you accidentally saw 4,000 families. Oh, ho, ho. Okay, no issues. See, it's good that you all are participating and trying questions on your own and trying to answer. Now, this is a very simple, quick question. It's more like unitary method, based on which there is this other question also, next question. Also, another important thing, let me say, although answers are important, but understanding is more important. Yeah. At times, there may be some human error, although, I try to be vigilant, and I suppose you are also vigilant. And if there be any human error that I may end up making, you would certainly let me know and you would point it out in the live chat. Yeah. I'm saying this just so that you focus on the learning part for sure and you don't miss out on learning part because of any trivial issues. Yeah. Any answers? There are 20 students. Yeah. And every student reads 5 newspapers, and each newspaper is shared by 10 students. So what is the total number of newspapers? More like unitary method. This is a very basic question that I have put here. Based on this, there is a good question that lies ahead. 100. Okay. Number of newspapers is what you want. Every student reads 5 newspaper, and Sanjeev is saying 10. Yeah. Okay. So 10 seems to be correct. Pay attention. 20 students. Yeah. And every student is reading 5 newspapers. Yeah. So total there is supposed to be 100 newspapers, but every newspaper is being shared by 10 students. Yeah. So effectively you may say what? There are total 10 newspapers. Yeah. So every student is reading there are 10 different newspapers, and every student is reading 5 different newspapers, and every newspaper is being shared by 10 students. So with that, total newspaper is supposed to be 10. Think about it. See, total would have been 100. Every student reading 5 newspapers, 20 students, 5 newspapers, 100. But the point is, every newspaper is being shared by 10 students also. Yeah. So overall, it is 10 newspapers. I suppose this is good Small, interesting question. Yeah. Although a bit on simpler side, now here we go for a better side. And this is going to be our last question of the day. And this is a bit, it looks a bit dirty in the sense, the way it is written. So let me explain it a bit. So here, union I equal to 1 to 50 xi is what? It is x1 union, x2 union, x3 union, so on and so forth, union x50. So that's what it means. Yeah. So that means union of, x1, x2, x3 till x50 is same as union of y1, y2, y3 till yn. And, those two union are the same set T. Yeah. Now, each of these xi set contains 10 elements and each of these yi set contains 5 elements. And each element of set T is an element of exactly 20 of sets xi, and each each element of the set T is part of or element of exactly 6 of the sets yi's. Then you have to find n. And where is n? N is here. Yeah, this n is what you have to find out. Think about it. It's very much similar to the previous question. Let's see how many of you can answer this. This is an interesting question, and this is the question that we end with. Yeah. So I suppose everyone is giving some thought. As you give this thought, you might have definitely read the question. Let me take you to the first slide, not this Happy Children's Day slide, but this slide, where we have talked about union. So when we say X union Y in this case, although element 2 is there in X and Y both, but we write 2 once only in this X union Y. Yeah, and it will be counted once only. So similarly, just as we have union of two sets, we can have union of more than two sets also. You may try thinking about it. Yeah. Any answer? So just as this newspaper question, if you have grasped the basic understanding of it, yeah, we have this question. Yeah, I think I have given you enough time to think. Mean is saying 30. Okay, let's see what the answer is. So here, pay attention. There are 50 sets xi. That means x1, x2, x3 till x50. Each set contains 10 elements. Yeah, just as there were 20 students and each student reads 5 newspaper, similar to that. 50 sets xi and each set xi contains 10 elements. However, each element is present in 20 of these sets. Pay attention here. Just as each newspaper is read by 10 students, so each element is there in 20 of these sets. Yeah. So this is the total number of elements in set T. Similarly, this will be equal to, there are n sets yi, each yi set contains 5 elements and each element is present in 6 of these yi sets. So with this understanding, if you see, what do you get? Uh, you essentially get 25 equal to n multiplied by 5 by 6. So n essentially turns out to be what? So yeah, kudos to all those who have got 30 as the answer, because 30 indeed is the answer. Yeah. So yeah, many of you have said 30 as the answer. Minu was the first one to say. So kudos to Minu for giving the correct answer. And then yes, Sanjeev and Selva Kumar, you have also got it right. So kudos to you. And all the others, I hope there was a there was some understanding that you got. And I hope each one of you, you know, could understand and appreciate whatever we have done in this session. Yeah. If there be doubt, you can let me know. We are towards the end of the session. Again, I wish each one of you a very happy Children's Day, and I wish all the best to all of you. All the best. Yeah. So I'm just waiting for responses, and then we are done. Because there is always that lag, that difference, right? So yeah, thanks for your appreciation, Selva Kumar. So we have taken some decent questions actually, from beginning till end. We have taken good, decent questions, I would say. So I'm happy that you like this session, Selva Kumar. And yeah, thanks, Sanjeev, for your appreciation. And everyone, all the best. Bye. Have a nice day.